Now you can see replica order consists of 4 T flip-flops. Now you want to say where is the flip-flop? See here, the flip-flop is here, T flip-flop. Now you might have studied T flip-flop. This T flip-flop is derived from D actually. You see inside, it's a D flip-flop. So now the T flip-flop is derived from T flip-flop. How you can make the connection? From the D flip-flop, the D should be connected with the one inverted gate to the D. So then that will become as T flip-flop. See, that is what the diagram here is made. So even this flip-flop also should be worked on the negative edge, because in the top level block we shown the clock is negative edge. So we must use negative edge only. Now you see the hierarchy. The T flip-flop is consist of what? One is D flip-flop. The another one is what? One more element is we are having one NOT gate also is there. So inverter gate. So every T flip-flop consists of TFF and the inverter gate. So this is the truth table of T flip-flop. Already we know. See here, when reset is 1, the Qn will be 1, then Qn plus. This will be your output. The Qn plus 1 is nothing but your output. This table is nothing but your characteristics table actually. This is actually they're not given. What is, where is T? Here you may think where is T? It is inbuilt, right? Because when I give reset is 1, automatically we need to preset the value of Q. Then automatically it starts to toggle. We are not giving any value to the T value, because you might have thought previously we studied JK. If you are doing from JK, JK is equal to 1, then you need to make it both are 1. This will become as T. This is what we studied earlier. But if you are designing the T flip from the D flip-flop, this will be like this. There is no T actually here, but there is a signal here. You can see this way I can consider as T actually, correct? See, the output of inverter is nothing but T. This is the input I can say. For example, I'm saying, because if you want to consider T means this is the T actually. So now let us see how it is written. I hope it is clear now. So this you know clearly how you have to write the module names and all those things and all. Now what I will do, let us go for the how to write the program for this. Yes, see how to write the programs now. Let us see. First you have to write the program for top level block. That is nothing but this is the top level block of the diagram. The 4-bit ripple carry counter here. So from this I can say see that module ripple underscore carry underscore counter is a module name. You can from this figure the inputs are clock, reset, then outputs are Q. This and all. So here they specified output comma input. We can write input comma output also. Both are same as I said. So Q, clock, reset. Next the output is Q with the size of 3:0 because it's a 4-bit. Next the inputs are clock and reset. Yes. So this is also over. Next you can see there are 4 instances are there. Instance in the sense these are called as instance. Okay. The first instance is nothing but TFF. You see this TFF0 is nothing but the instance label TFF0. You see only this first T flip-flop. Don't see the other things. You see only this T flip-flop. You don't see any other things. Now in this, first the output is what? This output is Q0. Yes, Q0. Next the input is clock. Yes, clock. Next one more input is reset. Same second you see. Second you see what will happen? You see now only the second T flip-flop now. You see only the second, don't see any other things. Now TFF, these are all module name. TFF, this TFF, all the 4 module names actually. TFF1, see here, we written TFF1. Then the output, first output is Q1. This is what here, Q1. Next what? The place of clock. This clock is something but what? Previous something but what? Q0. So Q of 0, then reset. Next TFF. Next is TFF2. TFF2 only you consider this now. So if you consider only this, so what is the output is Q2. Q2 is the output, right? Q2 is the output here. Next to the input clock. Clock is nothing but what? The previous output one is driving. That is the Q1 is driving. So Q of 1, then reset. Same the way for the fourth also. Q of 3, Q2 reset. Then end module. This is the main program written. If you run this program, you won't get any output. Why? Because the system will search where is this TFF. Nowhere we found the module of TFF. What you have to do? Now you have to write the separate program for TFF. So now you can see the TFF. First, you are writing the TFF program. See, this is what your TFF program. Let me draw. See, this is complete of T flip-flop. Then this is complete of D flip-flop. This is T flip-flop. This will be a D flip-flop. This is actually T flip-flop using D flip-flop. Actually, you can see this module TFF. Previously only you say, right? Now in the T flip-flop, what is the output? You can see the previous diagram. How the diagram will be there? So I need to show the diagram. I hope see simple diagram. See, this is what this next. Will be like this, will be like this. The here NOT gate will come, then here connected to this. This is D, this is only Q. So this will be a clock. This is clock. Then this will be a reset. See, this is something what totally is a D flip flop. T flip flop. It is T. Now you can see the total module. If I say what you are having, the output is Q. This is what Q actually. This is the Q. Q clock, then reset. The inputs are clock and reset. The wire is there. Where is the wire now here? The wire is here. You can see this. The wire is D. See this only. See, this is the wire. The output of inverter, because this one is connected to D. So this is something but a D. Now we'll write the program. Which model they written? The model which is written is gate level model. The programs are written in gate level. Gate level modeling used here actually, as you know that. So DFF is nothing but your module name of T flip flop, because the TFF consists of DFF and NOT gate. DFF 0. You see the D flip flop. What and all is there? The Q output is there. Then D input is there. Then clock will be there. Then reset is there. That 4 things are we use here. Next, NOT gate. Come for NOT gate here. Here, very important, this NOT gate and AND gate, XOR gate, all those things, these are the primitives. There is a syntax in the Verilog program. So the syntax is output comma input. Here the output of inverter is what? D. The input is Q. That is why here written D comma Q is written. It is a Verilog primitive. The Verilog has a primitive, is a N module. Now, when I run this program, still I won't get any output due to what? Due to this DFF, because the DFF is never found. Again, you need to write one more subprogram. You have to write for DFF. See, DFF. Now, DFF has the inputs are see. What is the order you given? The same order you need to follow. That is what I meant earlier also. See here, very important thing is. See this order. QD clock reset. So the way QD clock reset, see, same. Next, here in this output is Q, the inputs are D clock reset, the register is Q. Then now let us write in the behavior model. Here we used behavior model because it's very simple. Now here we used always at quasi reset or negate clock. Very important. You see here it can work. Your clock is negate or quasi reset. The sense it's asynchronous actually, because you are writing the program, it's an asynchronous counter, right? You remember the asynchronous counter, we need to use like this, passage reset or negate, because the reset will be happen during the edge of the clock or not in the edge of the clock. That is the reason here we have to use passage reset or negate reset. Now I'm saying if reset means what? Reset is equal to 1, then Q will be 0. Else, when the reset is 0, the Q follows the D. Then we'll go for module. Once we return this one, automatically what will happen? Then we need to run the top level module. When you are going to run the program, you need to run the top level module. How the hierarchy will be in the sense? See, example, in the Xilinx, if we see, this is 4-bit replicatory adder that will have 4 T flip-flop like this. 4 T flip-flop, 4 type trace. Then this T flip-flop we have 2 components again, that is DFF NOT gate. See, it will be like this, it will be there when you see in the system. I hope that is clear. Yes? Is there any doubt in this? Is it clear? Do you have any more doubt?